Hello, and welcome to, a special episode of Becca Breaks It Down. Um, Previously, we were writing linear function formulas, and here in example number 5, we're going to write another linear function formula. Okay. So in this scenario, federal income tax paid by an individual single taxpayer is a function of the taxable income. For a recent year, the federal tax for various taxable incomes is given in the following table. So notice that first row, we've got our taxable income, and the second row is representing the actual federal tax. It says, write an equation for the federal income tax paid as a linear function of the taxable income. Okay, so in order to write a linear function, I need to know the slope and the y-intercept. And right now, I don't know either one. Okay, so I need to find the slope, and I'm going to find the slope using my slope formula. So I can pick any two of the points on this table to do this. I'll just go with the first point and the last point. All right. So I'm going to find the y2 minus y1. So that means I'm going to have to go 3,239 minus 1,889. And I'm going to divide this by 24,000 minus 15,000. So let me do some calculations here. Let's see, up on top, we're going to have 1,350. And on the bottom, we'll have 9,000. And let me do my division. We are looking at 0.15, okay? So normally we write our slopes as like ratios. In a contextual situation, I think a decimal slope makes more sense when you're thinking about the meaning of it. Because like what we're saying here with the 0.15 is we're saying that the federal tax is increasing by 15 cents for every dollar of taxable income. Yeah. Okay. And if we kept it as a fraction, probably wouldn't make a lot of sense. No pun intended there. For the next step, y equals mx plus b. So one way you can write the equation of a line is to use the slope-intercept form and just substitute into that. So for me to do that, I need to pick a point on my graph, on my table. So I'll just work with that first one. And that'll be my x and y that I'm going to substitute into my slope-intercept form. So I'm going to have 1,889 is equal to my slope, the 0.15 times x, which is 15,000 plus b. And so what I want to do next is I want to kind of like simplify this and then solve for b. So I have already done all my math, of course, right? And I got like negative 361 for my y-intercept. So let me write my linear function. So remember, we are writing a function that's going to give us the federal tax t, right, as a function of the income I. So I'm going to have t is equal to 0.15 times I minus 361. So that's the linear function representing this situation. Okay. In part B, it says, what is the vertical intercept and does it make sense? Well, your vertical intercept has the value of b, so technically it's the point 0, negative 361. And does it make sense? Not really, okay? Because like 0, that's your income, and negative 361 is like your federal tax. Seems strange that if you don't have an income that you would be receiving money from the federal government when you do your taxes, because generally when you do taxes, you're getting back money that you've already paid. So like you would not get money back at tax time if you haven't like paid any money into the system. And like negative 361 is, I don't know, how can a dollar amount be negative in this scenario? So it doesn't make any sense at all. Okay. But this problem right here, the main idea, I guess, of it was writing a linear function given a data table. So basically you need 2 points, find your slope, choose one of those points, use your slope-intercept form, find your b value, that's your y-intercept, and then you can write your function. And that's how Becker breaks it down.